We'll start, I'm going to kind of do them together. So I'm going to do the exponent side and then the logarithm side because they kind of do go together. But I am going to go through them kind of fast because I want to get on to the other part. These are just basically the rules or properties of both of them with some examples. And it looks like almost everyone that's put answers into the chat box have got the exponents right. I mean, it's just a review from both your freshman and sophomore year. You should have gone over these. So if I have two exponents and the bases are the same, my bases are the same, I add my exponents together. So I have 2 to the 3rd times 2 to the 5th. That becomes 2 to the 8th. And sometimes you can work it out, or right now we're just going to leave it alone. But I would put in my calculator to the 8th, and I don't even know what you get. Somebody figured it out for me. But just put it in there and you can get your answer. On this one, it would be x to the 4 plus a negative 1, which is x to the 3rd power. Okay. So in logarithms, notice that this is multiplication. I want to go back to exponents for a moment. Notice that it's multiplication here, and I end up adding. So it's the same in logarithms. If I have multiplication, you can see that I'm multiplying m times n. It becomes addition when I separate it out. This is called expanding my logarithm. So I'm expanding it out. If I go backwards from the expanded form, the plus form, I can condense it down into one logarithm where it's in the multiplication form. So it's expanding or contracting them. And that's what we're going to do on the next, on the next couple pages. One page we're going to expand them, and one page we're going to contract them. Or condense them, condense them down to 1. But we're going to use these, and mostly we're going to use the first 3 rules on the logarithm side. Those are the 3 that we use the most. So if I have things multiplied together like m times n, it becomes log base a, or whatever base it is, of m plus log base a of n. So that means on this first example where I have log base 3 of 5 times x, I could rewrite that out as log base 3 of 5 plus log base 3 of x. And I can extend it out as many times as I had things multiplied together. Hence the second one, which has log base, no base, so that's base 10. Remember we talked about that. If that has no base, it's base 10. So log of 12 times b times c, that would just be log 12 plus log b plus log c. So, and if I had 10 things multiplied together, I'd have 10, when I expanded out, I've had 10 little logs with plus signs between them. Okay, so that's just how that multiplication works. And many times as I'm multiplying things together is how many little things I have, how many logs I have added together. That was Tony. Okay, so the next rule we're going to talk about is the division rule. So my exponent rule says if I have a to the mth over a to the nth, I get a to the m minus n. So if I'm dividing them, and they have the same base, then I subtract my exponents. And the important thing is that they have to have the same base. So they're both a's, so my bases are the same. So I've had, on my first example, I have 5 to the 3rd divided by 5, which would be 5 to the 1st power. So this becomes 5 to the 3 minus 1, or 5 squared. And you guys know that's 25. But I can leave it as 5 squared right now. On the second one, it'd be x to the 8 minus 3, which is x to the 5th. Okay, so on the logarithm side of it, similar thing. I have a division problem here, right? It's divide m divided by n, and then they're separated by a subtract sign. Now, this is the one I have to be a little carefuler with because it's the top, or my numerator, minus my denominator. Okay, so the numerator minus the denominator. So when I subtract this, notice it's log base a of m minus log base a of n. So It's the numerator minus the denominator. So if I rewrite log base 2 of 4 divided by x, I would get log base 2 of 4 minus log base 2 of x. And really, I'm just following these rules. I'm not doing anything special. I'm just following these rules. I'm doing what it says. That's all. Okay? And the second equation for that one is natural log. And same thing, natural log of x minus natural log of 11. I'm not solving for anything. I'm just expanding them out. That's all. Okay. Questions so far? Is everyone okay? Please, please, please. Honestly, this is probably one of the hardest things we're going to do so far this year. So please make sure you ask questions, okay? So, and then before we go on to the next pages, I'll kind of shrink these down so you can see the top 3 logs. Those are the important ones, and take a picture of it if you haven't written them down, just so you have those for when we go on to the next page. So for the third row, which is multiplication, I have a to the m to the nth. I'm multiplying those together. If I have a power raised to the power, that means I'm going to multiply my powers together. And that's that. So I'm just going to multiply them together. That means I've got 3 to the 2 times 5, or 3 to the 10th power. And the second one says x to the 4 times negative 2, which equals x to the negative 8. And I'm not going to talk about negative exponents right now. Okay, so we're not going to deal with those ones right now. So again, if I have a power, here, log base a of m to the nth power, what happens to that power? Well, they move that power down to the front. And I'm going to show you. Yeah, we can do this. So if I take this example that they have log base 7 of x squared, remember, what does x squared mean? What does it mean to be squared? Can anyone tell me what it means to be squared?
Multiply yourself twice.
Yeah, multiplied by itself, right? So I could rewrite this as log base 7 of x times x. Is that correct? So now I have a times. I could do, I'm going to kind of make this smaller so I can go and I can write it like I did up here with the times one. So I could rewrite this as log base 7 of x plus log base 7 of x, right? But how else can you write that? I'm adding the same thing twice, right? Does that make sense? I'm adding log base 7 of x and log base 7 of x is the same thing. So you can actually write that as 2 times log base 7 of x, right? The definition of multiplication is repeated addition. So I don't have to write the same thing over and over again. Look, I could take this exponent right here that is 2 and just move it to the front. And look what I get. 2 times log base 7 of x. I get the same thing as that if I do the repeated addition. Okay, so that's how that came about. So I can actually show you how that rule came about. That one's pretty easy to show you. I just didn't want to write it a bazillion times. So if it was cubed, I'd have another one and it'd be 3. Does that make sense, you guys? Is that okay? Yeah, no, maybe so. You guys are not talking to me today. That's okay. I have my exponent, and I usually just circle my exponents and put them where it's going to be. It's going to be in the front. So this is going to be x log base 3 of 6. That's it, done. Okay, so all I'm doing really is writing equivalent expressions for the logarithms. That's all. Okay. So the next section, where's our next section? The next section, we know that anything to the 0th power is 1. That's just a rule for our exponents. Anything to the 0th power is 1. So that means 6 to the 0th power equals 1. X to the 0th power equals 1. Anything to the 0th power equals 1. Okay? And then with a log, if I have, and we kind of talked about this yesterday, if I wanted to solve this, I could say 8 to what power equals 1? Well, 0. Remember, this is finding, a logarithm is finding the exponent that works with this. So 8 to what power is 1? Well, 0. Same thing here. The natural log of 1 is 0. Okay? That's all. Doesn't matter what base it is. It doesn't matter if it's a natural log. If it's to 1, my answer is always 0. Okay. This one's even simpler than the 0 one. It says a to the first power equals a. So 43 to the first power is 43, and z to the first power is z. Okay, so now let's talk about the logs, the log side of it. It says if I have a log base a to the a, this is like saying a to what power equals a. Well, of course, that's 1. It has to be to the first power. Okay, so natural log of e. So this is how I kind of think about natural log when I'm dealing with this. And it kind of makes more sense to me than dealing with it as a natural log, unless I'm putting it into the calculator. I just want to throw that out at you, unless I'm putting it into the calculator. So the natural log, ln is another way to write log base e. Okay, so if it doesn't work with natural log for me, what I'm going to do is I'm going to say log base e of e. Now look, I have the same base and the same number there, so my rule states that it equals 1. Because I can write e to what power equals e? Well, 1. Okay. And my second one says 4 to what power equals 4? Well, 1. Because it's to the first power. Okay. Whew. It's cold, you guys. It's very, very cold. And I think I wanted to take this out last time, but we'll just deal with it. We'll talk about it. Okay, so the exponent says a to the log base a of x. So as long as this base is the same and this base is the same, my answer is just x. So I have 3 to the log base 3 of 9. So 3 to here to the third power, those bases are the same, so my answer is 9. And then I can rewrite this one as log base, oops, got a little overexcited, e to the log base e of -4 equals, bases are the same, -4. I don't like that notation. We use different notation. Okay, this one says the same thing. If I have log base a, this base, and this is the same, it's just whatever my exponent is. Because I can write this as 12 to what power equals 12 to the 5th power? Well, in order for them to be equal, they have to have the same power, so it's 5. No base on this one, so it's 10 to what power equals 10 to the 1/2? Well, 1/2. Okay? So the last 3 rules are just basically identity rules, and they're going to help us solve some things when we get to solving, but we're not doing solving right now. What we're going to be using right now are these. Let me get them all in here. These top 3 rules. So if you haven't written them down yet, either take a picture of them or write them down really quickly. Those are the 3 rules we're going to go over. The 3 properties we're going to use today. And then we'll use some more properties. We're going to review it again tomorrow. We'll use some of the other ones when we're doing the solving on Monday and Tuesday. Or Tuesday and Thursday. I don't know. I can't remember how it's set up. Sorry. So let's see. Mia, what time are you guys leaving tomorrow? Like at 2?
Yeah, 2.
Okay. Okay, can I go on? Are you guys good? Okay. So basically now I'm going to use those rules. I'm going to use the properties to expand the expressions. So write each single logarithm as a sum or difference of logs and simplify if possible. So if I can simplify, I'm going to. Most of them I can't, just so you guys know, but some of them we can simplify and we have to, okay? So I'm going to work through these. We're going to kind of do this together. You know, normally I'm like, okay, I'm going to do these 3, and now you guys do these 3. But it might be like, okay, I'm going to do this. I'm going to give you like 30 seconds to work on it, and then we'll go on it, because I want to make sure that you guys get this. And I think you working a lot of these on your own is not going to be the way to do that. Does that make sense? Okay. So I'm going to look at it. I'm going to say, is it multiplication, division, power? What do I need to do? So on A, it is only multiplication, right? So it's only multiplication. So I'm going to rewrite this as a sum. Multiplication means I'm going to use the rule that says, and I think I'll just write them up here. That might be easy. It's going to be log base A of m times n equals log base A of m plus log base A of n. Okay, so that's the rule that I'm going to use. This one? Okay, what happened? Okay. Interesting, exciting. Here we go. So this will become log base 2 of 5 plus log base 2 of y. And that's all there is to it. Done. That's it. Okay. So I want you to try part B. So please do part B. And go ahead, I'll give you like a minute to type it in to the group chat, please. And I totally forgot to record. So sorry. So I'm going to use the rule that says log base A of m over n equals log base A of m minus log base A of n. So I'm subtracting them on C. So I've got, let's see, log base 2 of 19 minus log base 2 of x. Okay? Too bad there's not one right next to it again, but there's not. So for D, the third one, and then really I'm gonna use the third rule, and then really it's just a repeat of all 3 of these rules. This rule says if I have, trying to remember off the top of my head, log base A of m to the n, I get n log base A of m. The m and the n might be in the wrong place, but I'm pretty sure that's what it says as far as where the variables go. So I have a exponent here. I'm just going to move it to the front. So this becomes 3 log base 6 of x, and that's it. Done. Okay. Let's see. Let's do you guys think you could do E without me first? Do you want to try it? Like take a minute and try it and then we'll do it together. It's two different rolls together, so try that one. So this is using two rolls. So this says 9 times x squared. So that means I'm going to use the times one. So I have to use the first roll and then the exponent roll. So I have to do log. I hate it when I do that. So I have to use log base 5 of 9 plus, and then the square is only touching the x. So that would be 2 log base 5 of x. Is that okay? Yeah, Jessica. Nice. Close, except for the 2 in front of the 9, because it's not 9 squared. So now if I'm doing, yeah, Mel. If I'm doing the next one, I would do it that way, Jessica. That's beautiful for the next problem. Because the exponent is on the outside of the parenthesis. Does that make sense? See how this exponent's on the outside of the parenthesis here? So it goes to both terms. This exponent is only touching the x, so it only goes with the x one, not the 9. Does that make sense? I know you already said okay, but you're not the only one that I'm talking to now. So, okay. So, all right. So let's go ahead and do F. You guys are doing great, by the way. Good job. And then I'm going to do that one. So again, on F, I'm using 2 of the rolls. Oh. So on F, okay, I just gave you a few minutes to kind of think about it. So on F, this exponent goes to, this exponent's going both to the 7 because it's on the outside and the x. So I get 4 log base 2 of 7 plus 4 log base 2 of x. Okay? Yeah, nice. Yep. Because that 4 goes to both the 7 and the x this time. Okay? Nice job, you guys. Yeah. Okay, so we're going to talk about the square root again. I know that we talked about it yesterday and the day before, but unfortunately, we're going to have to talk about it again. How can I rewrite... If I have a square root, I want to rewrite it in exponential terms. So I want to write it as an exponent. So how can I write, let me come over here. How can I write the square root of w as w to what power?
The second.
So let me write it this way. So if I have the square root of 4, that equals 4 squared. It's not the second. Because this would be 2 equals 16, right? So that doesn't work. So it's not squared. Remember the rule. I wrote it down. Was it yesterday? Oh, we didn't have class yesterday. On Tuesday, yes, Paige, very good. I wrote it down. It's the rule. This is the rule. And they should have this. I wonder why she didn't have this rule on the exponents. Oh, well. This rule says if I have the nth root of a to the nth, that equals a to the m over n. And we did this, I did this yesterday for you, or Tuesday, so sorry. So my w is to the first power, my root is squared, so this would be the 1/2. Okay? So I can rewrite this problem as log base 3 of w to the 1/2. Now I have an exponent that gets moved in the front, so this becomes 1/2 log base 3 of w. So logarithms and square roots don't go together. I have to rewrite my square roots as an exponent. So rewrite this rule down, circle it, whatever you need to do, but write this rule down so you know it. So if you have a square root, you know what to do, okay? All right. So H is kind of a combination of both of our rules again. So I want to give you a minute to see if you guys can do it and how you feel about this one. So two of them, here's my exponent, so that's going to go in the front. So I've got 2 log base 3 of x, and then it's a fraction, so that's minus log base 3 of y. Okay. All right, I'm going to give you another minute to try I. This involves, okay, so here we go. So this says 9 times 10 to the x power divided by y to the second power. So I'm going to go ahead and write this out. So I get log base 3 of 9 plus 10 log base 3 of x minus, slide this over so I have a little bit more room, minus 2 log base 3 of y. And then it also says simplify if possible. I'm pretty sure log base 3 of 9, 3 to what power equals 9 is 2. So this is 2 plus 10 log base 3 of x minus 2 log base 3 of y. And there's my final answer because it did say simplify if possible. Okay. All right. Good job. So let us do J, K, and L. Put your answers in the chat box. Don't do M and N yet. Yeah, let's do J, K, and L. Okay, so on J, there are 4 things multiplied together. There's the 81, the x, the y squared, and the z. That means I'm going to have 4 logs. So if I go ahead and do this, I get log base 3 of 81 plus log base 3 of x plus, and there's an exponent, 2 log base 3 of y plus log base 3 of z. Okay, then it does say simplified. I think only one person simplified on here. Log base 3 of 81 can be simplified. This says 3 to what power equals 81. So this says 3 to what power equals 81. Well, that is 4. 3 to the 4th power equals 81. So this simplifies to 4 plus log base 3 of x plus 2 log base 3 of y plus log base 3 of z. Okay? And then the second one has 3 things multiplied together, which are log of 100 plus 5 log of x plus log of y. And remember, if it doesn't have a base, it's base 10. So 10 to what power is 100 is squared plus 5 log of x plus log of y. And then the last one, let's see, what's the last one say? 5 log base 6 of m plus 3 log base 6 of p minus log base 6 of b. Questions? So for m, I'm going to write this out first before I expand. I don't want to say write this out because I am going to write it out when I expand it. I'm going to distribute or simplify my exponents first. So this goes to everything in here, right? It goes to everything in there. So this becomes log base 2 of 3 to the third power, a to the third power, b to the sixth power over c to the third power, okay? So then I get, let's see, what do I get? Log base 2 of 27, that's 3 to the third power, by the way, plus 3 times log base 2 of a, plus 6 times log base 2 of 6, minus 3 times log base 2 of c. Okay. And on the last one, I have this lovely square root. And remember, I have to rewrite all square roots into exponential form first. Whew, I can almost forget what I'm saying. So this would become log base 3 of 4 to the x squared all over y to the 1/2. And then I'm going to just do what I just got done doing. I have multiplication and exponent and division. So I'm using all 3 rules. So I've got log base 3 of 4 plus 2 times log base 3 of x minus 1/2 log base 3 of y. Okay? A lot to take in, I know. That's expanding. Okay. Now we're going to go the other way. So I've expanded it. Now I want to take the rules and I want to condense them down. So I want to go from having many logs to having one log. I only want one log now. I want to make it look neater or simpler, I guess I want to say. So I'm going to do my rules backwards. So I'm going to try and write them backwards. So if I have log of m plus log of n, I should have log of m times n. And then the second one says if I have log of m minus log of n, I should get log of m over n. And the last one says if I have n log of m, that should become log of m to the nth power. Okay. Woo. So I'm going to go ahead and bring them back down to one log. So that means I'm going to have log base 3. I'm only going to have one log. I can write that down. And then I've got a plus and a plus. That means times. So I've got, and no exponents. There's no exponents, notice. There's no numbers in front. So it's just going to be x times y times z. Done. That's it. Now, I do want to say this. In Delta Math, sometimes they want the parentheses around the answers like this. So you just need to be careful. You'll be like, oh, I got the answer right. But it's not in the form they want. So sometimes you might want to look, go to the show example and look at how they want the answer entered. And I think this is one of those places where they're kind of sticklers about how they want the answer entered to get it right. So you might just want to check that out. I'm not sure, but I'm not 100% sure, but I'm pretty sure that this is one of those cases that you have to have a parenthesis in there to get the answer right. So what I do when I'm doing the Delta math is I just go, if I'm unsure how they want the answer, especially if you put it in and you get it wrong, you know you have multiple attempts to redo that problem. So when you go back, go to show example until you find one that looks like yours and see how they put in their answer. And then you're for sure going to get it, you know, if you did the work right, it's just going to be something like how they want the notation and how they want it entered. So just double check that. Okay, does that make sense? Okay. So on the second one, I think that again, shoot. Sorry, you guys, I think we're running out of time and I want to make sure we get these done. We have a plus. Ooh. We have an add, which means it's going to become multiplication. And then I also have an exponent. So this exponent, or this number in front, is going to become an exponent with that. So I have log base 2 of a times b to the third power. Or I can just write that as log base 2 of a b to the third. Questions? Okay, for the C, I have an exponent that's going to go with the x. And then I have a minus sign, which means it's going to become division. So I've got log base 4 of x to the second all over y. Okay, I want you to try. So the first one says log base 3 of 11 to the 8th times x to the 6th. I'm so sorry. I really can't put the variable in front of the number. That's just me. But if you wrote x to the 6th times 11 to the 8th, that is so totally fine. Also, that is correct. Okay. E, I guess I should say, is log base 2. And I've seen it a couple different ways in the chat, and both ways are correct. So I've seen it this way, which says x to the third times y to the third over z to the third. And I also saw log base 2 of x, y over z all to the third power. Both of those are correct. Okay, so either way you write that, E, that is correct. Nice job. And then F, log base 2 of 4 all over x plus 2. And everyone who put in answers for all three of them got them all correct. Nice job. Okay, so for the other ones, because we are running out of time, we're getting short here, I'm just going to go ahead and do the next 7 problems. If you have a question, make sure you're asking in the chat, and I will go over it in more depth. So make sure you're asking questions, okay? So this says plus, and there's no exponents. So this means I have log base 3 of x minus 1 times 5. And I can simplify that by writing log base 3 of 5x minus 5 in parentheses there. And that's it on that one. Okay, and then let's see, what do we have on the H? I have the natural log of 8 to the third times y squared divided by z to the 4th. Okay. And then, oh my Lanta. Okay, so we've got all pluses. And I've got a couple exponents here. Okay, so I've got log base 5 of 3 to the 1/4 times x all over y squared. And I can also write this as log base 5, the 4th root, oh, I'm running out of room, the 4th root of not x. Let me just rewrite this down below. Log base 5, the 4th root of 3 times x all over y squared, because it's a 4th, so that means it's some sort of root, so I can do that. I will accept either answer. Let's see. So this is a subtract sign, and this is a subtract sign. So that means it's a division. So I have natural log of x divided by 3y. Okay. No questions? Okay. So I've got a plus sign and a plus sign and an exponent here. So log of a, b, and c to the 1/2, or I can write that as log base a, b square root of c. Okay. And then let's see what I've got. Okay, I've got a square. I've got a plus sign. Whew. So log base 5 of x minus 1 squared times x, or I might write that as log base 5 of x times x minus 1 squared, just because it's a little neater. And then the last one, how are we doing? Oh, great. Okay, so I've got an exponent and a plus, exponent plus, exponent minus, and a minus. Okay, so log of 2 cubed times m cubed divided by p cubed times q. Done. Okay, questions? Awesome. So we have just over 10 minutes to work on your Delta Math assignment, and make sure you can ask any questions that you need to on Delta Math, okay? So I think it's 10 questions doing this. So let's get on Delta Math.